Hey, welcome to this lecture for Intro to Backend Development. This week, we're going to be talking about authentication. This is an optional lecture for everyone who wants to learn about authentication so that they can implement it for their hack challenge. So let's get started. So for some review, this entire semester, we've been learning about HTTP communication. As you know, this is the protocol that we've been using to send information between clients and servers being the computer and code that you've been building out. And HTTP requests contain information such as the URL, query parameters, the method like get or post, and body, which is any other information. And responses, which go back to the client, will contain a body with some information and a status code. So let's think about what our applications need. Most of our applications will want to incorporate some sort of users, meaning that there needs to be some special information specified towards a person or many people. This can include settings, some content, like if you have your own profile, and social features. So we definitely need permissions for resource access / manipulation. You don't want someone else making a request under your name saying like, hey, I want to post something. And you have really no control over, who is sending the request here. So we need a way to identify users making requests, which is what authentication is all about. So how do we verify who's sending requests? Let's take a look at something like this. We have done this in our, I think either one of our assignments or demos, but here's an example of a request post API posts, and there's some information with a link and a title and a user. But remember when you were testing this, really you are some nebulous client sending a post information like this with a user, and you could put literally any user you wanted. You could put Alicia, you could put Elena, you could put, I don't know, Martha Pollock, and no one, the server isn't stopping you from making that post request, which is really, really unsafe. We want to prevent this as much as possible. Whoever is sending this request to our server needs to actually be who they say they are. So let's dive right into authentication. So we need to include some additional information in our request for user identity. And we will validate server requests based off of the provided credentials in your request. And we also want to create some specific permissions based off of your user identity. So depending on who you are, maybe you're a member, you're an admin, whatever, you can do some things, but maybe not others. You can view your friends' posts, but maybe not your friends' posts or something like that. Let's talk about registration and login. So this might look familiar to you. In fact, pretty much any website you use will have some sort of login system, your email or username and password. You would put something like maybe your Cornell email and a password, and you would register for an account. Of course, you have to register for an account before you log into that account, right? So what is going on here? These credentials are being sent to your database when you're making a request to sign up for a new user account. You're sending over your username or email and password. It's going to be sent to the database. It should be encrypted so that any malicious agent with access to the database somehow isn't actually able to decrypt this information. And of course, it should be stored in the database. So let's say you're logging in here. Now our green button has turned from like sign up to login. You've created an account. Now you want to log into your account. You're sending over your credentials again to the database. And now the server is checking, is this user in the database? And if so, does the password they typed in match the password we have saved in our database? And we should authenticate you if this pair exists. And what we mean by authenticate, I will explain soon. First, let's talk a little bit about HTTP request headers. How are we storing this information, like our credential information in our request? So just as our request has a body, requests also have headers, which contain metadata about a request. So this isn't necessarily like your post information, like what's the title and what's the body of our post, but rather this is some stuff about a request. So here are a few. There's a lot that we can explore, but the most important ones we're going to be talking about today is the cookie and authorization. So cookie, delineating a user state information, and authorization, which is how we will pass credentials when we use token authentication, and HTTP basic. You can actually take a look at your request headers. If you make a request in your browser, you can look into the networking and you'll see that there are a lot of things here. So there are a couple of ways of authentication that we're going to talk about today. You can think of them as HTTP schemes, and there's basic, session, and token. Basic being sort of the most straightforward, but not necessarily the best, and session and token being better and actually pretty similar. So let's go ahead with HTTP basic. The gist of this is that you want to encode your username and password in your request. Then you will cache our encoded credentials on the front end. Then you will send the encoded credentials with every request to the server, and the server will take those credentials and validate those encoded credentials. So here's an example of a request. Maybe you are on Google Drive and you want to get your files, you being a specific user, right? So this is going to look a little bit like what we have here. And you can see under this metadata for authorization, we have some information about your username and password. Authorization will have this format. It will say basic for HTTP basic, and then it will have a string. And what the string is an encoding, specifically base64, of your username and password. Now, note that I'm saying encoding and not encrypting. Just as you can encode something, it is actually very easy to decode it. The reason why we encode it is to pretty much just like make it shorter, especially if you're sending over a lot of data. But you can go into a base64 encoding, decoding website on Google right now, paste that in, and it'll give you something. So this is not safe. You can see why HTTP basic is really basic. After all, you're literally sending your username and password with all of your requests, which will be quite unfortunate, as we will see soon. So to give a timeline of what this looks like, first you register. You as a client will be like, hey, I'm abc123@cornell.edu. My password is something. So these credentials would be sent to the server. The server will create a new user. More specifically, it will create it'll just create a new user, and then it will return a response. And I'll be like, hey, you are a new user. Here's some information about your new user. That is you. Afterwards, the client will send over its encoded credentials. So that's your base64 encoded username and password to the server when you're trying to log in or make any sort of request. Then the server is going to decode the credentials. Again, very easy to do. It will validate the password, so just check if the password matches the one in the server, and return a response with the data that you're looking for. So this could be like if you go to Google Drive and you're trying to look at your files. So some benefits, it's really simple, so meaning that it's very accessible. The users don't have to rely on a specific front end. After all, you pretty much just need to send some information in your request, and HTTP is our standard here. And any client would be able to use the service. Some drawbacks. So again, your username and password is exposed in each request. You can see all of this information if you go to your browser and click on like developer tools and networking and just look at that data, look at the metadata. Also, your username and password pair is stored on your front end. That is also pretty dangerous, and it's going to be removed on closing the application or browser, or if you just manually remove it. So you don't have a lot of control over, like how long this username and password is being stored there. It's kind of wishy-washy as to how safe this is. And sort of most importantly, the security of these requests is dependent on HTTPS. So in short, HTTPS is just HTTP, but your requests are encrypted, meaning that it is a lot more secure than just HTTP. Meaning that if you don't have, your server, a server that supports HTTPS, then any malicious agent is able to look into your request and pick out this data. So you really wouldn't be able to use this HTTP basic authentication with servers that don't support HTTPS. Next, we're going to talk about HTTP sessions. So the gist here is we send the username and password to our server. The server will validate our credentials, and then the server is going to generate a session with an associated cookie. So you've probably heard of cookies before whenever you go on any websites like, hey, this website's going to store some cookies, hope that you're okay with it. If not, please leave our website, or I guess don't leave because no one really cares about it. Cookies is just a fancy word for a small piece of data that is stored on the client side. So that's it. It's just like a little bit of data that's stored on like your browser. So after the server generates a session with a small piece of data that's saved on the front end, which is what number 4 is saying, we're caching the cookie on the front end. Then every time the client makes a request, it's going to send a cookie. And this cookie is going to identify the user. So let's talk a little bit about like what a session is. What is a session? And the analogy that I like to use is sort of like the little wristband you get at a festival if you're over 21 and you're able to purchase alcohol. I don't know how niche that metaphor is, but I'm going to explain it to you right now. So hopefully it's okay. When you go to a music festival, of course, there are going to be minors there. You're going to have people who are like 16, 17, 18, but you're also going to have vendors that are selling alcohol. And because it's so chaotic, you need some way to easily pick out who is, legally able to buy a drink and who isn't. So the metaphor here is that if you're a person who's 21, you will need some sort of authentication that you are someone who's over 21 whenever you buy something. And the easy way to do this without having to pull out your ID every single time you try to buy a drink inside is that you would get a wristband at maybe like the front desk, and you're like, hey, I'm going to give you my credentials right now, one time only. Here's my driver's license, and it says that I'm over 21. Whoever's at the front desk is going to be like, yeah, seems like that checks out. So they will make sure that your credentials run through. They might like scan your card or something, and then they'll give you a wristband, and you're going to wear this wristband. Then whenever you go to buy a drink, or I guess like make a request, then all you have to do is show your wristband and not your credentials again. And so that's a lot safer because maybe you don't want everyone handling your driver's license. You don't know what they're going to do with it, but you don't really care about this little piece of paper that's wrapped around your wrist. And after the festival is over, you can just throw that piece of paper away and all is good. So with HTTP session, we have the same thing here, authorization, basic, blah, blah, blah. I'm not going to go through this again, but I will show you when you look at the cookie. So there is a cookie, again, there's cookie metadata under your request, HTTP request header, and you can see it right here. The important thing that you're going to want to look at is that there's a session ID that you send over as a client. And this session ID is going to be what identifies the session associated with, I guess, your authentication. And this session information is actually stored server side in memory instead of with the client. The client's only going to have like the session ID. So once a client registers, the server is going to create a new user, and it's going to create a new session that's sort of like kind of associated with this new user. And this session is going to be saved in memory. Then the server is going to return the cookie, but more specifically the cookie ID. And the client is going to save that cookie ID. Then whenever the client wants to make any sort of request, it will just send over the cookie ID. And the server is going to look at the session code. It's going to look at all the data that the session contains, like expiry and things like that. Then it's going to validate the session based on the cookie ID that was given, and then it will return a response. What if the session is actually expired though? So like, we gave you permission to use our services for like 1 day, but now 1 day has passed. It's going to return a response that's like, failure, your cookie has expired. So the client will have you re-log in. So essentially, once you lose that cookie, you have to log in again to get that cookie back. And then now we validate credentials, we create a new session, we return the new cookie, and it is back. So benefits is that you don't have to continually send over credentials, right? You don't have to always send over your password and your username, only when you want to get a new cookie. And you are able, you as in the server developer, are able to tune the expiration time between user convenience and security. So, the longer you allow a cookie to be active, it's a lot more convenient for the user because they don't have to sign in again. But you do run the risk of, maybe some security issues. Then you can also, make the expiration time really, really short. And essentially, the user just has to log in pretty frequently, and that might not be ideal either. So this is really up to you. The drawbacks to HTTP sessions is that, again, the session data is stored in memory on the server. So if you have I don't know, thousands, tens of thousands of users trying to, save their sessions, that might, make your server start to bloat pretty quickly. So might want to reconsider that. Also, you've probably encountered this before. If the client or the user deletes the cookies from the browser, then they have to re-authenticate. That could be good. I guess that could be bad, but it is kind of annoying. It's very much dependent on the client. Finally, we're going to talk about HTTP tokens. And this is what we are going to teach you how to do in the demo. So this will look actually quite similar to HTTP sessions. We're going to send the username and password to the server. The server is going to validate, and the server will generate and return a unique access token. So instead of a cookie, this is an access token. This access token is going to be saved on the front end, and then similar to cookies, but not quite, the front end is going to send the access token on every request to identify the validated user. Okay, so what does this token look like? Now in our authorization, instead of basic, we have bearer tokens. So you don't see the word basic anymore, it is now bearer. And the access token is in the form of an encrypted string here that will be generated using hash, and it looks quite nice. So the biggest difference for our purposes is that HTTP token authentication requires that we save, or not, I guess necessarily requires, but majority of the time is that we save these access tokens and the relationship between access tokens and users in the database. It's not stored in memory. It's not going to bloat up your server memory. It is in our database. And this is one an example of the relationship. You might have the token ID. It's going to be associated with a user, which is really convenient. Now you have this extremely explicit relationship between users and tokens instead of sort of with sessions floating around. It's just pieces of data kind of existing in the server and on the client. And we have our access token. So we have token expiration. So we can design our access tokens to expire after a period of time. That means accidental exposure of access tokens don't really have lasting effects because eventually, the access token is going to expire and it can't be used anymore. And the really nice thing about tokens is that users request new access tokens after existing ones expires with what's called a refresh token, which is a token. It's one-time use, and it will replace the previous access token. And I'm going to explain how this is pretty nice soon. First, here's sort of what a schema might look like for our token table. We would have the token ID, the user ID of the user associated with the token. We would have an access token. That's what's actually authenticating us. We'll have an expires at column, which is saying when our token is going to expire, and then we'll have a refresh token. So similar to before, we have our registration of a new user. We create a new user, and then we'll also create new tokens associated with that user. And then we're going to return the tokens. So the client will save the access token, and whenever they want to request from the server, then they will pass along the access token in the authorization metadata. The server is going to validate the token. It's going to execute whatever it was supposed to do, and it will return the response. But what happens if the token is invalid? What if the current time is past the expires at time? It's going to return a response saying, hey, it's expired. And here's the beauty of tokens. Instead of resending the credentials, aka the username and the password to the server to re-authenticate the user that way, the client will also have its refresh token that was given to them. And now this refresh token replaces the username and password in order to get a new access token. So we're like, hey, here's a refresh token. The server's like, oh, yep, that's a valid refresh token. Let me just create some new tokens for you. I'm going to create a new access token and a new refresh token for next time your new access token expires. And then it's going to return those tokens. And that is beautiful. You don't have to re-log in again. So the user credentials are sent way less frequently because of the refresh tokens. Again, you can tune the expiration time if you want to. And tokens are more scalable than session cookies, again, because they're stored in our database and not in our server memory. So yeah, that's a brief explanation of authentication. At least I would say it's a pretty high-level explanation. You can really get deep into this stuff, especially if you sort of do some research on HTTP. But hopefully that is enough to get you started for authenticating your very own apps. And Elena's demo, demo 7, will show you how to use access tokens and refresh tokens in your app. So good luck.